Hello everyone, it's a pleasure meeting you all in my mathematics class. Today let me take problems in partial differential equations. Partial differential equations. See, what is the difference between a partial differential equation and a ordinary differential equation? Ordinary differential equation, you see that that is y will be, for example, you see that y will be a function of x only. There will be one independent function and one dependent function. So you saw that it becomes an ordinary differential equation. That is, the equation consisting of derivatives will be called as a differential equation. And you see that in a ordinary differential equation, there is one dependent variable and one independent variable, nothing more than that. But when you come to partial differential equations PDE, here you'll have a function z. This function z will be a function of, it is a dependent function which depends on two variables. For example, you see that the area, if you take the area of a rectangle, it depends on two variables, that is x and y, the length and breadth. So you see that when you are going to differentiate that, we have to differentiate partially only because it depends on two independent variables. So if a function depends on two different variables and if a differential equation is formed, then such a differential equation will be called as a partial differential equation, wherein you find the derivatives which are partial derivatives and not ordinary derivatives. Okay, that is partial derivatives either with respect to one variable only. Okay, so a differential equation wherein the derivatives or partial derivatives will be called as the partial differential equation. Now let us have this in our mind, and say when you are having z is equal to f of xy, conventionally we take dou z by dou x as p, dou z by dou y we take it as q, dou square z by, this is a second derivative with respect to x, we call it as pqr, then dou squared z by dou x dou y we take it as s, and dou squared z by dou y squared we take it as t. So these are all conventional notations that we use. Dou z by dou x, partial derivative with respect to x is taken as p, partial derivative with respect to y is q, and the second derivative, partial derivative with respect to x twice is r, and partial derivative with respect to x and y will be s, and partial derivative with respect to y twice is taken as t. And with this conventional usage, we will start doing problems in partial differential equations. First of all, how to arrive at the partial differential equation is an important aspect that we must understand. For example, I will take this problem. Consider 2z is equal to x squared by a squared plus y squared by b squared. Now you see that from this you can very well understand that z is a function of x and y. Now we have to get the partial derivative of this particular equation. That means we have to solve, that is, get the partial derivative of this equation from the partial derivatives. The derivative will be, the partial derivative will be what? A partial differential equation, a differential equation in which the derivatives are partial derivatives, nothing more than that. Okay, now what I do is, see, I take this, form the partial differential equation eliminating the constants. Eliminating the constants. Now this can be written as, this is 2z into 1 by a squared of x squared plus 1 by b squared of y squared. Now if I can eliminate this 1 by a square and b square, then I see that I can get the partial differential equation. How that is done? See, differentiate, you call this as your 1, differentiate 1 with respect to x. So when you differentiate this one with respect to x, 2 into dou z by dou x is equal to 1 by a squared into 2x plus 0, since dou y by dou x is equal to 0. And x and y are independent variables. When they are independent variables, dou x by dou y is equal to 0 and dou x by dou y is equal to 0. That is, if you differentiate one with respect to the other, the ratio is 0. Dou x by dou y is equal to 0, dou y by dou x is equal to 0. Whereas dou z by dou x is because z is a function of x and y. It is a dependent variable depending on the two independent variables x and y. Okay. Now this is what we have. So this implies, see, from this I can get 2p is equal to 1 by a squared into 2x, which implies p is equal to x. See, I write it as 1 by a squared into x. I will count it as 1 by x. So this implies what? So this implies 1 by a square is equal to p by x. P by x. So I am able to get, see, I am able to get the value of 1 by a square. So if I substitute in this is automatically I will be getting the partial differential equation. Now differentiate 1 with respect to y. When you differentiate with respect to y, this is 2 into dou z by dou y is equal to, it is 0 plus 1 by b squared into 2y, since dou x by dou y is equal to 0. As I told you, they are independent variables, therefore their derivative is equal to 0. And this implies what? This implies, see, 2 and 2 will get cancelled, giving you, it is q is equal to 1 by y squared into y. This implies 1 by y squared is equal to q by y. So substitute this in this. So you have got 1 by a squared you have got value and 1 by b squared you have got value. See, substituting in 1, this we will call as 1. Substituting in 1 we get, substituting in 1 we get 2 is, see what is that you get? 2 is equal to, what is the value of 1 by a square? 1 by a square is equal to p by x plus q by y. Oh, sorry, this one. See, I write it here. 1 by a squared is p by x into x squared plus q by y into y squared. This implies 2z is equal to, so 1x and 1x goes off, 1y and 1y goes off, giving you px plus qy. That is px plus qy is equal to 2z. Know that this p and q are what? Dou z by dou x and dou z by dou y. Now see that this is the partial differential equation. This is the partial differential equation of this equation 2z is equal to 1. This is by method of elimination of the constants. There is method of elimination of a general function will be there. That I will be doing it in the next class. Okay. Now understand how this is done, and conventional usage of the notations you must be familiar. Then only you will be able to understand. So this is all about this problem. Now let me come to the second problem. This I have here. You are asked to solve this differential equation here. You are asked to solve this differential equation given here. See, what is it? This one. See, it is dou squared z by dou x squared is equal to a squared z. See, from the problem you can understand that z is a function of x and y. But here you must know that this differential equation is purely a second derivative of the function with respect to x, second derivative. So you see that here, see z is a function of xy. Z is a function of xy. But from this I can understand this is a partial differential equation or differential equation with respect to x. So I can write this as, see, d squared minus a squared of z is equal to 0, where d squared you can take it to be even d squared by dx squared, nothing wrong in this. So that is auxiliary equation is m squared minus a squared is equal to 0, which implies m plus a into m minus a is equal to 0. This implies m is equal to a or m is equal to minus a, and therefore auxiliary complementary function is, see, there is no function on the nothing, that is, you don't find anything on the right hand side. So you see that this will be this is a homogeneous equation, and you see that there is no there is no function, you don't find any function on the right hand side, hence particular integral will not be there. For example, you see that if it is like this, d squared y by dx squared plus 2 into dy by dx plus y is equal to 0. Now you see that the solution for this problem is y is equal to complementary function plus particular integral. This particular integral will come only when you have got some function on the right hand side. If it is not there, this will be 0. So you will stop only with what? Finding the complementary function. So here again the same thing. You don't find anything on the right side. It is 0, and therefore there is no complementary function. Therefore, in a particular integral, there is no particular integral. Only complementary function is there. The complementary function itself is the solution to the problem. Complementary function and solution is equal to, so you see that z is equal to a into e to the power of ax plus b into e to the power of minus ax. So this is what we have. But you must know that this z is a function of x and y. Since z is equal to x of v of x, y, see, this y variable should come. So a and b cannot be constants. A and b are constants. But see, since z is a function of x and y, a and b have to be functions of y. So let z be equal to phi 1 of y e to the power of ax plus phi 2 of y e to the power of minus ax. Call this as your 1. Now you see that, let us try to find out what is phi 1 and phi 2. If I can find what is phi 1 and phi 2, my problem is over. See, to find phi 1 of y and phi 2 of y. See, this phi 1 of y and phi 2 of y can be determined using the conditions given in the problem. See, to find phi 1 y using the conditions given in the, so we will find what is phi 1 and phi 2 using the initial conditions here. So let us start doing this. So this is my solution. This is my solution. The only thing is I have to find what is my phi 1 and phi 2. Now let us start by, see, let us take this now. See, take this. Z is equal to phi 1 y e to the power of ax plus phi 2 of y e to the power of minus ax. Now differentiate with respect to x now. Therefore, dou z by dou x is equal to, differentiate with respect to x, you will get a into, I will straight away write here, it is phi 1 of y e to the power of ax minus phi 2 of y and e to the power of minus ax. See how I get this? Because phi 1 and phi 2 are treated as constants, and this e to the power of ax is a into e to the power of ax, whereas e to the power of minus ax differentiation is minus a into e to the power of minus ax. So this is what we get. Now See, you apply the any conditions here. What is the condition? Given when x is equal to 0, when x is equal to 0, dou z by dou x is equal to a sin phi. Therefore, see, dou z by, you write therefore a sin y is equal to a into phi 1 of y. When you put x is equal to 0, e to the power of 0 is 1. So, into 1 minus phi 2 of y into 1. So, this implies you cancel a on both sides, you get phi 1 of y minus phi 2 of y is equal to sin y. So, you keep this. This is one of the equations that you have got. So, I have got one of the equations, namely involving phi 1 and phi 2. Phi 1 of y minus, see, it means that phi 1 is a function of y. Phi 1 of y minus phi 2 of y is equal to sin y. Now, what is the next one? Differentiate 1 with respect to y. So, what is that you will get? Dou z by dou y. This e to the power of ax is treated as a constant. So, phi 1 dash of y plus e to the power of minus ax into phi 2 dash of y. So, I differentiate this with respect to y. So, I get it as phi 1 dash of y plus phi 2 dash of y. Now, see, dou z by dou y is equal to 0 for x is equal to 0. It is given dou z by dou y is equal to 0 when x is equal to 0. So, when x is equal to 0, dou z by dou y is equal to 0. So, substituting here, what is that you will get here? So, 0 is equal to e to the power of 0 is 1, e to the power of minus ax, that is also 1. So, you get this as phi 1 dash of y plus phi 2 dash of y. Now, you see that let me integrate on both sides. So, this is nothing but what? It is, see, it is like this. Dou phi, see, dou phi 1 of y plus dou phi 2 of y is equal to 0. Because it is nothing but what? Dou phi 1 by dou, this is like this. Dou, see, it is like this. See, dou phi 1 divided by dou y plus dou phi 2 by dou y is equal to 0. This implies dou phi 1 plus dou phi 2 is equal to 0. Therefore, integral of dou phi 1 plus dou phi 2 is equal to integral of 0 is a constant. A constant c. So, integral of dou phi 1, integral of dx is x. Therefore, here it is phi 1 plus phi 2 is equal to a constant. So, you see that from this, so this implies phi 1 plus phi 2 is equal to a constant. Now, let me solve this. So, you call this as your, see, you have got here two equations. So, you call this as your 2, call this as 3. Now, you get phi 1 of y minus phi 2 of y is equal to sin y. Phi 1 of y plus phi 2 of y is equal to c. C is a constant. So, what is that you get here now? So, this from this I am getting two equations here. So, I am going to solve these two equations for phi 1 and phi 2. That ends the problem. So, what I do here is that now, so you add this is your 2 and this is your 3. See, 2 plus 3. See, 2 plus 3 means what? These two will go off giving you what? 2 phi 1 of y is equal to c plus sin y, which implies phi 1 of y is equal to c by 2 plus sin y by 2. Then 2 minus 3, see, again, see, 3 minus 2, right? This minus this, so these two will get cancelled, giving you what? This will become plus, so you get this as what? It is 2 phi 2 of y is equal to c minus sine y, which implies phi 2 of y is equal to c by 2 minus sine y by 2. So you see that I am able to get phi 2, I am able to get phi 1. Now if phi 1 and phi 2 are obtained, now you can substitute these values here. See what is that? Here you have got here, see? You have got here, so z is equal to something. Substitute here, you will get the answer. Now let us substitute and get the answer. Now, so you call this as 2, 3, you call this as your 4, call this as your 5. Substituting 4 and 5 in 1. See, this is, we have taken it to be 1. Substituting 4 and 5 in 1, we get z is equal to, what is your phi 1? Phi 1 is c by 2 plus sine y by 2 into e to the power of ax plus c by 2 minus sine y by 2 into e to the power of minus ax. So this implies z is equal to, I will correct the coefficients, c by 2 into e to the power of ax plus c by 2 into e to the power of minus ax plus it is sine y into it is e to the power of ax by 2 minus e to the power of minus ax by 2. So this is what we get. So this implies, you can take this c outside, so you can write this as e to the power of ax plus e to the power of minus ax divided by 2 plus sine y into within brackets e to the power of ax minus e to the power of minus ax divided by 2. So this is equal to, therefore c is equal to c. This is nothing but cos hax plus sin y into sin hax, as cos hax is equal to e to the power of ax plus e to the power of minus ax